Hey guys, Astro Brain Physics here. Today to explain about a topic that I mentioned in a previous video about stars, and that is the black hole. So to begin, what does a black hole look like? Well, a black hole doesn't look like this. This is just artist's depiction of it. If you ask someone, what does a black hole look like? It would be a trick question. Black holes, you cannot see them unless light is being curved. But when light is being curved, it actually looks similar to this when it comes to sphere. And this is a jet of light feeding into this black hole. So today we're just going to cover the non-charged type of black holes, which are your basic stellar mass black holes and your supermassive black holes. Now to understand this, I will need to explain different parts of black hole. I'll explain these in greater detail than it shows on here. So first of all, you have the event horizon. Even though it's not a proper depiction of a black hole, the event horizon is right here. A horizon is the furthest point that you can see events happen. Event horizon is this point. Furthest point outside of observer can see events happen. As beyond this point, light cannot escape. Nothing can escape from this point. This is like the point of no return zone. So what comes in never comes out when you hit the event horizon. Next, you have an accretion disk, which I'll show you in a minute. This is an accretion disk. It's a material that falls into an orbit around a black hole, stellar dust, etc. It maintains an orbit. Some of it eventually gets sucked into a black hole, as the black hole feeds on everything. Then you have the photon sphere. Photon sphere is the point where light maintains an orbit. The light spins around the black hole, maintains an orbit in it, and then gets sucked in. You have an ergosphere. An ergosphere would be here. It's right outside the black hole, and it's not an atmosphere, but it's part of one. You can escape from this point if you go fast enough. Speed of light. You have to go to speed of light to get out of the ergosphere. Just one last part to a black hole. That is the singularity. Singularity is the point at the center of the black hole, right pictured right here. It's the point where space-time is infinitely curved and no volume is defined. This may not make sense since the laws of physics break down at this point. But infinite curvature means that things start to get weird here. Now, time to explain how you would die going into a black hole. If you were going into a stellar mass black hole, which is about the size of our sun, collapsing something into Schwarzschild radius the size of our sun, tidal forces on you would be much greater than they are on the Earth. So your feet would be pulled into the center faster than your head, and you begin to spaghettify, or turn into long strands of atoms, be swirled into the center, the stream of atoms. Larger black holes, you could actually get into them, but the danger is not spaghettification. The danger is heat. When the mass of a star gets pulled in, our sun alone is 24 million degrees Fahrenheit. Rotation causes it to heat up even more, and if this material hits you, it's over. Even though you could go in a little in stellar mass. Supermassive. Supermassive black holes are formed when stars billions of times the size of our sun collapse on themselves. Into a point this small. Black holes are formed when matter condenses, any type of matter actually, condenses into a point known as a Schwarzschild radius. Matter cannot go anymore. It's an infinite point where gravity is infinite. I believe I've pretty much covered black holes, so this will conclude it for this video. Stay tuned for the next videos on neutron stars.